This is section 2.6, graphing inequalities, and we're going to take a look at some selected evens through this section. First one we're going to take a look at is problem number 2, and we're to match each inequality by its graph. So we have 4 different choices to choose from. So if I want to take a look at this, alright, I say, well, this is in slope-intercept form, so it crosses the y-axis at 2, and then my slope is 2 over 3, so we'll rise 2 and run 3. So up 2 over 3 from there. Now, because this has an equal sign with it, this is a solid line versus a dashed or dotted. That looks something like that. And then if I choose the point 0, 0, I want to see if that satisfies this inequality. So I say, alright, 0 is less than or equal to 2/3 times 0 plus 2. So I end up getting 0 is less than or equal to 2. And that is true, so 0, 0 does work. So everything on this side of the line is true, and everything on the line makes this inequality true. So we kind of just shade it like this. Moving on to question number 4. Question 4, or going back to question number 2, if you take a look at your choices, the answer there would be C. Now, when you get to number 4, I want to put this in slope-intercept form first. So you want to solve for y. So you get negative 3y is greater than negative 2x minus 6. We want to divide everything by negative 3. This gives us y is greater than, almost forgot. When you divide by a negative, you're supposed to flip the inequality. So now it's going to be less than. So this is 2/3 x plus 2. So we take a look at this one again. You're going to go up to 2. That's your y-intercept. And then from there, you're going to rise 2 and run 3 to there. Now this is going to be a dashed line or a dotted line or a broken line because there's no equal sign with the inequality symbol. So the line is not included as part of our graph. Alright, now let's choose the point 0, 0 and see if 0, 0 satisfies this. So 2 times 0 minus 3 times 0 is greater than negative 6. So you get 0 is greater than negative 6, and that is absolutely true. So 0, 0 did work, so it's everything on this side of the line, but this time not including the line, would satisfy this inequality. So all these points over here make this true. And that is letter D if you're looking for your matching. Letter D. Moving on to question number 6. 6 says for us to graph or to check to see if this point satisfies the inequality. Is it a solution? So we plug in the point 0, 0. So 0 is less than or equal to the opposite of 0, which is 0. So we get 0 is less than or equal to 1. Is this true? Yes, 0 is less than 1. So yes, 0, 0 does work for this inequality. It is a solution. Moving on to question number 8. Again, does 8, 1? Is that a solution to this inequality? So we plug in our point, alright, with the y being 1 is less than 3/4 times x, which is 8, minus 5. Now, I want to do some canceling here. It goes in twice, once. So I get 1 is less than or equal to 6 minus 5. So 1 is less than 1. Is 1 less than 1? No, 1 is equal to 1. And because there's no equal sign with this inequality, we'd have to say no on this one. Moving on to question number 10, we're taking a look at the graph of this inequality. So I want to put it in slope-intercept form. It is. And you need to know 2 things. Your slope, which is y equals mx plus b, so it's equal to negative 1, or you might think of negative 1 over 1. And my y-intercept, or my b value, is 3. So the point is actually 0, 3. So I know that at 0, 3 it crosses the y-axis. And from there I'm going to go down 1 over 1. So rise, down 1, run 1. 1 over 1. Alright, and because this is an equal sign there, that means it is going to include this line. So I want to make sure that this is a solid line. Draw it as straight as I possibly can. Alright, so every point on that line satisfies this inequality. However, there's more points. So I choose the point 0, 0, and if I see if it works. So I say 0 is less than or equal to the opposite of 0 plus 3. So I get 0 is less than or equal to 3. And 0 is less than or equal to 3. So I know 0, 0 does work. So all the points on this side of the line satisfy the solution, or satisfies the inequality. Question number 12. I am graphing this inequality as well, and again, fortunately, it is already in slope-intercept form. So my m is equal to 3, or you can think of it as 3 over 1, and my y-intercept, the b is 5, so my point is 0, 5. So I go up to 5, so 1, 2, 3, 4, 5, and there's where it crosses my y-axis, and then from there I'm going to rise 3, 1, 2, 3, and run 1. It's a pretty steep graph. And because this is not an equal sign, does not have an equal sign with the inequality, that means it's just going to be a dotted line or a broken line, dashed line, however you want to say it here. Everything on this line does not make the inequality true. However, there's still a side that does work, so I choose the point 0, 0. It's an easy point to plug in. And I say, alright, is 0 less than 3 times 0 plus 5? Well, this is 0 is less than 5. Is 0 less than 5? Yes. So 0, 0 does work. So everything on this side of that line will satisfy the inequality. They're all solutions. Okay. So that's your answer to question number 12. Taking a look at question number 14. 14 is a special type of graph because there's no y here. So hopefully you know that if it just is x, that's a vertical line. Alright, it's not going to have a slope. It's undefined, so it's a vertical line. And x is always 3. So 1, 2, 3, x is always 3. So 3, 0, 3, 1, 3, 2, 3, 4, 3, negative 1, 3, negative 2. It's all of these solutions. And it is a solid line because it says x is greater than or equal to, or excuse me, less than or equal to. Now, I want to try to choose a point, so I'm going to choose 0, 0 and see if that works. So is 0 less than or equal to 3? Yes. So 0, 0 works, so it's everything on the line and everything to the left. That means everything to the right of this line does not make this true, but everything to the left will make this true. So there's the answer to number 14. Moving on to question number 16. This time we have y is less than or equal to 2. So my slope is 0x. So when you have a slope of 0, think of it as a horizontal line. You're going 0 miles per hour. If you are skiing, the slope is, there's not one. You're on flat ground. Alright, but my y-intercept is at 2. So I know this goes through the point right here, and it's a horizontal line. So this one looks like this. Alright, now to try to choose the point 0, 0, so I say is 0 less than or equal to 2? Yes, 0 is less than or equal to 2, so it's all the points below the line and including the line, since it was an equal to sign with it. All the points from the line and below satisfy this inequality. Moving on to question number 18. 18 says y is greater than or equal to the absolute value of x plus 2. Now, absolute value inequalities or equations have a special graph. They sort of look like a V. And if you do any study on it, you'll know that we have something that typically would look something like this. X minus h plus k, where my hk is my vertex, where this turns, all right, a minimum or maximum point. So in this case, I have no h, so it's 0, and my k is 2. So 0, 2 is where this turns. So up at 0, 2, right there. And then you just kind of make a V out of it. All right, if you were to plug in a points in a table, you'd see it, but it looks something like this, a shortcut. And because this is an inequality, and because it's an equal, and it is a solid line, all right? And then we have to check to see if the solutions outside of the V work or inside the V work. So again, let's choose the point 0, 0. All right, so we say, all right, 0 is greater than or equal to the absolute of 0 plus 2. Well, the absolute value of 0 is 0, so 0 is greater than or equal to 2. Is 0 greater than or equal to 2? No, it's not. So 0, 0 does not work, so that means our solutions are everything that's inside of these lines, all right? So if you think of it this way, it's all these solutions in here. They satisfy this inequality. All right, and the points on the line. Moving on to question number 20. Again, we're to graph. So if we're going to graph this, I want to put it in a graphing form or slope-intercept form. All right, we're always going back to this. Y equals mx plus b. All right, and just treat this inequality like it's an equation. All right, so I want to solve for y. So subtract my x's, and I get negative y is greater than or equal to negative 2x plus 4. I want to make this positive, and that's going to switch my inequality symbol. We change all the signs. All right, so there it is. So my m is equal to 2, or 2 over 1. And my y-intercept, my b value is negative 4, so 0, negative 4. So this crosses at negative 4, so 1, 2, 3, 4. It crosses the y-axis at negative 4. And then from there I'm going to rise 2, 1, 2, and run 1, right there. Now this does have an equal sign with the greater than symbol. So I'm going to have a solid line. And again, with inequalities, you have to figure out which side of the line to shade. So I choose the point 0, 0, and I see if it works. So 2 times 0 minus 0 is greater than or equal to 4. Well, 2 times 0 minus 0 is 0. Is 0 greater than or equal to 4? Well, the answer there is no. So 0, 0 does not work. So I want to shade everything else on this side of the line then. Since 0, 0 did not work, I don't want to shade 0, 0. All right, so all the solutions to the right of this line satisfy this inequality. When I move to question number 30 or 22, again I want to put in slope-intercept form. So I want to solve this for y. So 3y is equal to negative x plus 9. Divide everything by 3. So y, and that shouldn't be equals, that should be less than. Y is less than negative 1/3 x plus 3. So I go up to 3, 1, 2, 3, put a point, and then I go down 1 over 3. 1, 2, 3. Rise over run. Now, this is going to be a dashed or dotted line, since there's no equal sign with the inequality. All right, so trying to draw as straight as I can there. All right, and then I have to check the point 0, 0. So 0 plus 3 times 0 is less than 9. So I'll get 0 is less than 9. Is 0 less than 9? Yes. So 0, 0 does work. So it's everything on this side of the line, but not including line, that satisfies this solution, or satisfies this inequality. All right, all these points are solutions. Moving on to question number 24. I have to graph this, so I want to put it in slope-intercept form, which means you just solve for y. So I get negative 2y is less than or equal to negative 3x plus 8. Divide by negative 2. And when you divide by negative, that switches your inequality symbol. So you get 3 over 2x and that's minus 4. Now, what I do is I know two things. My m is 3 over 2, and my y-intercept is 0, negative 4. So I go 1, 2, 3, 4, down to negative 4, and then from there, rise over run, or just think of your slope as rise over run. So up 3, 1, 2, 3, and over 2, 1, 2. Now, this inequality does have an equal sign with it, so I am going to have a solid line. Alright, and I want to choose the point 0, 0, see if it works. So 3 times 0 minus 2 times 0 is less than or equal to 8. You could choose any point. 0, 0 just happens to be easy. So you get 0 is less than or equal to 8. Is 0 less than or equal to 8? Yes. So I want to shade the 0, 0 side. So all these points are solutions, or is a solution, to this inequality. All those points are solutions. Moving on to question number 26, I have an absolute value inequality. So you're going back to kind of remember this. Absolute value of x minus h plus k, where this is just a translation of your absolute value graph. So hk is my vertex, turning point. So what I take a look at is my h then is 1 and my k is 2. So I know this thing at 1, 2, right there, is where it turns. Alright, now this does not have an equal sign with it. That means this absolute value inequality has a broken or dashed or dotted line. Alright, and they simply look like a V. With kind of slopes of like 1 and negative 1, if you want to think of it that way. Alright, and if you made a table, you could see that, but making tables would be a little bit, it would take too long, so you can just kind of use this translation of this function. And then what we do is we simply check the point 0, 0 and see if it works. So we would say 0 is greater than 0 minus 1 plus 2. So we have 0 is greater than, that would be negative 1. The absolute value of negative 1 is 1 plus 2. So we say 0 is greater than 3. No, 0 is not greater than 3, so 0, 0 is not a solution. So it's all the points inside of this V-type graph that satisfy this inequality. Right? So all those points inside of there are solutions. Moving on to question number 28, we have this graph and we're supposed to write the inequality statement for this. Alright, so we're supposed to write an inequality describing each graph. Alright, so let's take a look at some things. Think of your slope-intercept form, y equals mx plus b. Do the same thing. Let's see if we can figure out where it crosses the y-axis. I think we can. It's right there if you look very closely. So now my b value is equal to 1, 2, 3. Alright, so 0, 3. And my slope, if you take a look at it, it does cross right down there. So that's down 1, 2, 3. And to the left, 1, 2, 3, 4. So it's down 3, which would be negative 3. And to the left, which is also negative. So really my slope then is 3/4. Okay, I have to have a positive slope since this line is going up from left to right. Alright, so then I know that it would be something like y equals 3/4 x plus 3. The only problem is this is an inequality. Everything on the top side of this line is shaded, so that means all those points work. And it is a solid line, so we know a little bit more than it's y is either less than or equal or greater than or equal. And since it's shaded above, that would just simply be greater than or equal to 3/4 x plus 3. So this is the inequality statement of this graph that is shown. Moving on to question number 30, we have an absolute value inequality. Alright, so again, we're kind of thinking of in terms of this, y is equal to the absolute value of x minus h plus k, where hk is your vertex. So if I take a look at this, I'm going to go to the left 2 and down 1, 2, 3. Alright, so left 2, negative 2, negative 3. That means this would be, h is going to be a 2, and it's going to be a positive 2. Alright, or we would think of this as, since the minus sign is supposed to be there into our equation here, it's going to be x minus negative 2, which is really plus. Alright, so what I have then, it is y is equal to the absolute value of x plus 2, the same thing as minus and negative, and then plus k, so plus negative 3, or we could just say minus 3. So my hk, we said, was negative 2, negative 3. Now, this is an inequality, so it's not going to be equals. It's going to be either less than or greater than. We know there's not going to be equal sign at all because we have a dashed line. So what we can do is we can choose the point 0, 0 and see if it works. Alright, so let's try 0, 0 with this equation right here. Y is greater than the absolute value of x plus 2 minus 3, and see if it works. So 0 plus 2 is 2, the absolute value of 2 is 2, and then 2 minus 3, that's negative 1. So is 0 greater than negative 1? Yes, 0 is greater than negative 1. So we know this would work, so we should have everything at 0, 0 shaded, but we don't. That means we have the inequality symbol wrong. So we just change this to simply be less than. And if we tried less than, it'd be 0 is less than negative 1. And that's not true, so we wouldn't shade it, so that would be everything outside of 0, 0. So this then is our inequality statement for this graph. Y is less than the absolute value of x plus 2 minus 3. Moving on to question number 36, we are to graph each conjunction or disjunction. This is a conjunction, since we use the word and. Alright, so it's going to be the intersection of these two. So if we take a look at the first graph, it's y is greater than negative 2. So negative, that's a horizontal line at negative 2. Alright, and I'll use different colors so we can see here. And it is greater than negative 2. That means it's going to be, everything is going to be above it, up here. Now, our other one, y is less than 3. Well, that's going to be up to 3. 1, 2, 3, right there. And that's going to be another horizontal line. So these are parallel lines. And it says less than, so if I do this one in a different color, say purple, less than will be this, all these points here. Now, since this is a conjunction, conjunction is the intersection of these two. So where do the yellow and purple intersect? Alright, well, they intersect in between these two lines and everything in between the lines. So our solution set then, and I'm going to try to do this in green here, everything inside of these two lines satisfy both of these at the same time. Alright, so you just kind of shade inside there, however you can do it. Alright, so everything in between the two lines, and including the lines, satisfy this solution. I know I didn't see that there for a second. I'm glad I saw that. This top line is actually supposed to be dashed, because it doesn't have an equal sign with it. So that top line answers are not included. Alright, but the bottom line is included. It is solid. So watch out for your inequality symbols. Look for those. And that concludes our selected evens from section 2.6. Thanks for watching.